Hi students. In this video lecture, I am going to discuss about 3D computer graphics projections. 3D computer graphics projections. We'll see types of projections and why we are using projections. What is the use of projections in 3D computer graphics? It is one of the topic that we have to cover as per the syllabus. I hope that you are preparing seriously for the forthcoming examinations. So be serious and prepare well and be ready for writing of examination in any point of time. I hope that you are preparing very well manner. So now you are going to see the projections. Already I covered transformations in my last class, types of transformations and the techniques that you are using in the transformations, in the mathematical expressions and objects and everything we have seen in the last class. I already posted that video in YouTube. You can click it and you can observe it. I don't want to say you only prepare and only watching my YouTube video, because I am only inciting you to study well. I don't want to tell exactly depends on my video, because I am not interacting that much way. We don't have that much rapport here. Just I am posting the video because I have many constraints. I don't have that much technical advancement here to use and to project everything in well manner so that you can understand clearly. So please try to understand. Just we are posting this video for inciting you and you can prepare well manner. If you are not clear this topic, you can go through another channels also. In your language many videos are available. So even one topic, multiple videos are available in different languages. So here, if you can go through the websites, we can go through the another YouTube channel, we can go through the online. So many means and ways are there to understanding of the computer graphics, each and every topic in detailed manner, because we have the such a resources. Now, as for our syllabus, I am going to discuss about projections, computer graphics. Look at here. Before going to start projections, I want to give the definition of projection here. What is a projection? Look at here. This projection is nothing but in the three-dimensional objects are made using computer graphics. Why you are using three-dimensional objects are made using computer graphics. The techniques used for two-dimensional displays of three-dimensional object is called projection. So look at here. Technique used for two-dimensional displays. You're using a technique for two-dimensional displays of three-dimensional objects is called projections. Look at here. The technique or the way or the mean or the instrument, we can say that the instrument or the way, the mean, the procedure, the phenomenon that are using, the technique used for two-dimensional displays. We are using technique for what? Two-dimensional displays of three-dimensional objects is called projection of three-dimensional object. So because three-dimensional objects are there, that three-dimensional objects we couldn't draw exactly using of the three-dimensional x, y and z axes. It's not possible. So when it is not possible, we are using a technique to draw the 3D objects to represent that object in a 2D form. 3D object is there. I want to draw this 3D object using of the two-dimensional. I can display this 3D object in a 2D way. We are using to convert this 3D object into this 2D object drawing. Not we are exactly converting 3D object into 2D object. It is not possible. I am telling drawing of a 3D object into the two-dimensional. The drawing of 3D object and two-dimensionally we are using technique. That technique is called projection. Okay, this is called projection. So simply we are drawing the 3D objects into a two-dimensional objects. The technique we are using projection. Look at here. I hope that you understand. Now, several types of projections are available. Several types of projections are available. So, parallel projection, perspective projection, orthographic projection. Several projections are available. You know what is the projection? Just 3D object one draw in a two-dimensional way. For that you are using technique. The technique is called projection. Several projections are available. Among them, parallel projection, perspective projection, and orthographic projection. We will see what is a parallel projection in detailed manner. Parallel projection. What is a parallel projection? Look at definition only. Look at the definition here. Parallel projection. In this projection point on the screen is identified within the point in the three-dimensional object by a line perpendicular to the display screen. The architect drawing, that is plane, front view, side view, evolution are nothing but lines of parallel projection. Lines of parallel projection. So I want to give you an example for that. What is telling here? Identify what is the projection is drawing screen, drawing a screen. Draw the object of 3D on screen, two-dimensionally. That is called projection. What is telling here? Identify within the point in the three-dimensional object by a line perpendicular to the display screen. Display screen, for example, take, now listen, here, let's take this example, okay, take this example. Now here, perpendicular means this is the perpendicular, okay, this is the perpendicular, this is the perpendicular, because these are the. Now listen, what is the parallel here? Draw this object on the screen. So what is the parallel projection is nothing but here this parallel projection means this is a screen here, one draw this object. So here one line is going, from down one line is going, these both lines are parallel. One line is going from down here, another line is going here, both lines are parallel. These both lines are going like this, okay, like this. So one line from the top, another line from the, one line from the top, one line from the top, another line from the bottom. The two lines are going like this parallel, okay. This is the infinite distance, infinite. There is no chance to both lines are joined together. The lines are going like this, okay. So draw the height of the line exactly. So using of this parallel line, what is the advantage? We can measure the object with the exact measurements. We can measure the object with the exact measurement, because this top is the bottom, in between the size, this is the height of this object, and we can measure it. This is exactly we measure it, okay. This is the exact measurement, okay. This is the height of the object, and one line is going from top, another line is going from down. So this is called parallel. This parallel line we can draw. So based on this height, based on this parallel line, we can draw an object on the screen. So this type of parallel lines will not coincide, will not join together. It's infinitely is going, it's not joined together. So from the center, it's not joined from the center. So the object can draw on the screen the same distance with the exactly measurements using of the parallel projections. So what it tells, for example, I will tell you, when you look at a tree, when you look at the one pillar, so that pillar top and bottom. So when you look at the pillar, top and bottom may not be joined together. If you want to draw a picture, the pillar picture, you keep the screen behind of it and just draw the exact picture on that screen. How can you draw? So you will send the one line from the top and send another line from the bottom, and this top and bottom lines are giving the exact measurement of that pillar. So both are not joined together. So this type of projections called as parallel projections. We'll see. Using of these parallel lines, that we can draw diagram on the screen, and we'll see in detailed manner. Once again, look at the definition. The projection point on the screen is identified with a point in the three-dimensional object by line perpendicular to the display screen. The architect drawing plane, front view and side view. Plane, front view and side view. And elevation are nothing but lines of parallel projection. Look at here. And parallel projection, front view, for example, this is the, just identify this. Now this one is there. Okay. This one is there. What is telling? When you draw this picture, when you draw this image, imagine there is already object, you want tree, you want to draw this one on a screen. This is called the technique use the projection. And imagine top view and bottom view parallel lines are going. Now listen, these parallel lines are going. Okay. Now what is telling here? When you draw a picture, when your projections are there, architect drawing plane means we can draw this side, this means this side, okay, it means this side we can draw this, okay, and next thing we can draw top, we can draw this one. This one is called, this one become a front view and this one become a side view, and this is the plane, front view. Look at here, this is the front view, this is the side view, front view, okay, but we can't see the back view, because when you are putting this one, you can see the front view, and then you can see the side view. You can see the front view, okay, this is the front view, and you can see the side view. This one is the side view, but you can't see what you can't see, back view we can't see, because it will not visible on sheet on, okay, and this will show you the front view, side view and plane. This type of projections called are parallel projections. We'll see detailed manner. Look at here, I will tell you. I want to elaborate to understanding of the parallel projection. I want to elaborate furthermore. Look at here. Try to understand what is the parallel projection. Parallel projection discard z coordinate, and parallel lines from each vertex on the object are extended until the intersect the view plane. It means what? Intersect the view plane. Look at here. This is a 3D object and this is a screen. Okay. Listen, this is a, and this one is a screen. Behind of my hand is screen and an object is there. Now, what is the telling? Here z coordinate is absent. Here that is I am telling this is a 3D object. We can't draw 3D object exactly. That's why converting 3D object into 2D object. We are using one technique. The technique is called projection. Now listen, this is a screen. My hand is a form is a screen and this is an object. What I am doing here is telling parallel projection means so top and bottom. Okay, top and bottom. From the top one line is going. Okay, from the top one line is going. From the bottom one line is going. When this top line is going, intersect with the plane, and the bottom line is going, intersect with the plane. So this vertex and this vertex. Okay, here vertex is there. Just here this vertex is there. This vertex going to intersect the plane, and this vertex also going to intersect with the connect with the just here screen is there, and this line going to meet the screen, and this line also going to meet the screen. Okay, this line going to meet the screen, and this line also going to meet the screen. This is a parallel projection. Now listen. Until this both line extend until intersect with the plane. Intersect with the plane. Plane is nothing but a screen. Okay, back side. In parallel projection, we specify direction of projection instead of the center of the projection. So direction is not going to meet the center. This parallel means what? Similar. This is similar. So it will not meet together. Parallel lines are never going to meet together. Parallel lines are never going to meet together. Look at here. Parallel lines. Okay, what is telling? We specify a direction. This is a direction and this is a direction. A projection instead of the center projection. So instead of the center projection, okay, it will not going to meet. We will see what is the center projection next time. Now, parallel projections, the distance from the center of the projection to the project plane is infinite. Project plane is infinite. In this type of projections, we connect the projected vertices by line segments which correspond to the connection on the original object. Okay, original object. So this distance, infinite distance. It can go meet anywhere. It's go up to. It will go parallel lines will go. This line will go infinite. That is infinite. This line will go. This line will go. That is infinite. It's not meet anyone at anyone. Infinite. Projected vertices line segments which correspond to connection on the original object. We will see. Parallel projections are less realistic, but they are good for exact measurements. In this type of projections, parallel lines remains parallel and angles are not preserved. Various types of parallel projections are shown in the following hierarchy. Now listen. Parallel projections are less realistic. Parallel projections are less realistic. Parallel projections is nothing but technique that we are using drawing of the 3D into 2D. That is all. Not that much less realistic. Less realistic. Are good for exact measurement. The measurements are same. What is the exact height we can say? What is the width we can say? Because the height and because parallel lines are going to give the exact measurement. But shape, can identify the shape. It's going like this. We can exactly tell the height of this one. But can you, this one, look at here. This one is the not square. Rounds are there here. Rectangle. So you can, this one is the shape. This shape is the rectangle or this shape is the square. And this case is the rhombus. How can you know that this is not that much realistic? This is going, but it not gives realistic, that means the exact shape of the object. That's why it's telling not less realistic. Okay, it gives the exact measurement, what is the height, but it will not tell the exact real object. That is called parallel projections are less realistic, but they are good for exact measurement. In this type of projections, parallel lines remain parallel because this parallel remains parallel. It will not coincide. It will not join together because join together. I will show the figure. You can easily understand this. Parallel remains parallel lines, and angles are not preserved. Various types of parallel projections are shown in the following hierarchy. Look at here: parallel projection, orthographic, and oblique. Orthographic and oblique both are the parallel projections. Again, orthographic, front view, side view, axometric, cavalry, orthographic, parallel projection, orthographic, oblique, and again top, front, side, isometric, and cavalier, cabinet. These are the parallel projections. So now we will see orthographic projection. What is orthographic projection? The orthographic projection, the direction of projection is normal to the projections of the plane. There are three types of orthographic projections: front projection, top projection, and side projection. What is the top view, front view, and side view? If you see this one, this is the top view. For example, this object, this one is top view, and this one is the side view, and this one is the front view. What is this? This one is front view, top view, side view. It is the orthographic projections. So look at the figure here. Top view. Just imagine, actually this is the image. The middle one is the image. What is the middle one? What is the middle one? Middle one is the image. What is the middle one? What is the middle one? Middle one is the image. And this image, that is called this figure or this object. What is top view? Just a minute, look at here. What is this? Parallel lines are connected with the parallel lines are connected. Just draw the parallel lines. So here one line where the vertices are there. Just join the vertices. So okay. So this is the top view. What is side view? Look at here. This one. You can easily understanding. I will tell you. Wait. So what is side view here? This one is the side view, and this one is the top view. Okay, this is the top view. Again, this one is the front view. What is this? Front one is like a rectangle. The side one also a rectangle, but this one is with the three boxes: side view, front view, top view. This is called ortho projections. So this is ortho projections. The lines are normal lines. Okay, ortho projections. Ortho projection. Look at what is the once again. In ortho projection, the direction of projection is normal to the projection of the plane. There are three types of ortho projections. What is normal? Simple. Where the vertex is there, we will draw the vertex. Where the line is there, we will draw the line. Just exactly we will draw all the parallel lines. Side view, top view, and front view. This is called ortho projections. Orthographic projections. Next one is the oblique projections. Oblique projections are cavalier and cabinet. Cavalier and cabinet. Cabinet. So cavalier and cabinet both are the oblique projections. So we don't want to see that much detail. Tablier and lever projection and cabinet projection. So these are isometric projections. Isometric projections, orthographic projections that show more than one side of an object are called axometric. Axonometric orthographic projection. Orthographic projections that show more than one side. Orthographic projection that show more than one side of an object are called axonometric orthographic projection. The most common axonometric projection is an isometric projection. Isometric projections, where the projection plane intersect each coordinates axis in the model coordinate system at an equal distance. In these projections, parallelism of lines are preserved but angles are not preserved. The following figure shows in the isometric projection. So, parallel projections. What is the parallel projection we have seen, or the orthographic projection we have seen? Obliques. So just you look at the oblique, cabinet, calvier, both are. Next one, isometric projections and diametric and triometric. Isometric, trio. So this is also a projections. Now apart from that, so very important one is perspective projections. Here parallel projections, orthographic projections and perspective projections. These are the very important. Parallel projections, orthographic projections and perspective projections. That's why I want to emphasize on these three as per your syllabus. I want emphasizing on these three as per your syllabus. What is a parallel projection? Parallel projection is nothing but drawing of the 3D object in a 2D, and these lines are intersect on plane, and this gives the exact measurement, but is less realistic. So this way of projections are called parallel projections. So they are not joined together. This is infinite distance from the center, not joined together. This type of projection is called as a parallel projection. Next one, orthographic projection. Orthographic projections are normal on plane, normal on the plane, and it will show the top view, side view and front view, top view and side view. It will show the three views, orthographic projections. And we'll see the oblique, not that much important as per our syllabus, just we go through it. We want learn more. Just look at the perspective projections. What is the perspective projections? And perspective projection is nothing but here the top view and bottom view will join together. Not the parallel projection, but this both are going to meet at one point. Both are going to meet at the one point. Kare babu. Abba. Ara. एक बार देखा हो अगर मैं नहीं है कंप्रेस करना है
एडिट करना है सर, कुछ नहीं सर, ये है ना। से है। आपका एस्पेक्ट रेशियो जो रेशियो में चाहिए आप कम से कम टोटल अपनी इसमें डाल दीजिए, नहीं तो ये रहने दीजिए। ये वाला सर, ये वाला इतना हो गया सर। अब ये है ना सर, इसके आगे कर्सर है आपका, यहाँ पे जाकर